So we've been looking at how to anticipate patterns, but we've been using just pictures, right? Well, today what we're going to do is we're going to look at some number patterns, and we're going to look at a way to arrange them so that it's easy to see. And we actually talked about this last time, I think. We talked about putting things in a table to make it easy to read. But if we didn't, then that's fine. We're going to talk about it a lot today. So we're going to talk about patterns, but instead of drawing pictures, this time we're going to look at patterns that are just number patterns. Okay? And how to find out what the sequence would be and how to make sure we organize it well. All right? So, here we go. So today what we're going to do is we're going to talk about a way of describing patterns and sequences. Remember, a sequence is just a way of a sequence of numbers that go in a certain pattern, right? And we're going to do that with the use of tables. Now, yes, I don't know why it's a jellyfish with glasses. We're holding a table, but I told you it's not like... I would not have chosen the graphics on some of these, but oh well. A little levity in mathematics never hurts. So look at the following sequence. So you have the numbers 7, 10, 13, and 16, right? Well, you can write these in the form of a table. So, sorry, started reconnected. Okay, good. So, you'll see that all they did to create this table, right, is you just put a separate box for each number. Yeah? And put each number in a box. There are 4 numbers, so you got 4 boxes. Make sense?
Can you scroll down?
Yes, you're always going to see the goofy thing part. Okay. That's not the part we're concentrating on, though. Okay. So if you put them in the table, just look at how much easier it is to read. If you have a long list of numbers, that's a lot harder to read than if you put them in a table where there's only one number in each box, right? So that's the point behind tables, is we were able to organize our work a little better, okay? And so it's easier to read. So it's often useful to describe to use a table to describe where a number fits in a sequence. So, in other words, the first number is this, the second number is that, the third number is that, etc. And so, from the previous slide, we knew that the first term, or the first number they gave us, was a 7. The second one is a 10, the third one's 13, and the fourth one was 16, right? Remember those numbers from the previous slide. So, what they've done is they've rearranged and created a new table that now puts that information together, right? So I know by looking at this table that 7 was the first number, right? Yeah. And so the third number was what? 13, right? So organizing your work in a table is really good, and you can use it for lots of different things. You're going to see as you move forward in algebra and you move forward in statistics and any mathematics classes that you go to in future, that organizing your work in a table is going to be big. And later when we talk and we start graphing these things, you're going to see that a table really helps you find out what you need to do when. Okay? So here's a table, and this is the number of items, and this is the actual number value, right? So the first value was 7. The second value was 10. These numbers go together, don't they? Could any other number be the second number? No. Nope. Could 10 be anything but the second number? No. So once you think of them this way, it also locks the values together so that we know which one has to be second all the time, right? For this particular sequence. Because if you rearrange the numbers, you're also changing the sequence, the pattern, aren't you? Right? If it goes 7, 17, that's a different pattern than 7, 10, right? Yes? That thing? Yeah. That I made? Yeah. Oh, okay. That y'all think of as the hashtag, but that is actually the symbol for number. Okay, sorry about that. I'm not used to hashtags. I'm not very tech savvy. Yes. Okay, here we go. So let's look at some more patterns and creating some tables. And we're going to learn a little bit more about some things about tables. Okay. Sorry, the internet is not cooperating with me. So here we go. So we can add some more information to make the table easier to understand. Because think about it. If I came into the room and I said, I want you to come up here and work this on the board. Does that mean all of you? What would make it easier for me to decide who I want to come to work on the board? So yes, exactly. I would call someone's name. Gabby, you just got volunteered, okay? No? All right. So I would call someone's name, right? And say, come to the board, right? And that makes sure that you know exactly what it is you're talking about. Well, the same kind of idea makes a table a lot easier. If you name your table and name your numbers, then you can be very specific and know which one I mean. And if you look here, for the term number, they've named that just lowercase n, right? So it's the first number, the second number, third number. So can you see why they use the letter n? What's that standing for? Number. The number, yeah, good. And at the bottom, they used a capital T, right? So 7, 10, 13, 16. Those are the numbers from the sequence that we already looked at. Okay, and they just use T for the value of the term, and that's where they got the T. And why they capitalized it, I have no idea. Oh. I knew that was coming. So, right? But, okay, one of the things about capital letters is sometimes they use capital letters because they're never going to change, but neither is the other number. So don't worry about capitals or lowercase. But the N, so if I said, if N is 3, then T must be what? Yeah, the term, but what number actually? 13, right? Okay? Each one has a value. So if I say, if T is 16, then N must be 4. Right? Do you see how we're reading this? So we're just giving them a name. Excellent. And they're just giving you an example of another weird table. I have no idea why, but it's pretty cool. Yes?
I figured out, I can't remember what it's called, but to get from n times, it's n times 3 plus 4.
This particular pattern?
I don't know how to say it.
Okay.
So it's like n times 3 plus 4 is that's the rule. The rule. For that table.
For this particular table?
Yeah.
Oh, cool. All right. We'll see. So what I want you to do real quickly, right? Remember, this is participation. So you've got a table. What I want you to do is just raise up your hand, and I'm not going to call on anybody specifically, but just raise your hand, and we will fill in the gaps for this particular table. So here's our pattern, 13, 15, 17, 19, and 21. So who can tell me the first number? Yes? 13, exactly. So they're already in order. All you need to do is just write them in the order. So what's the next one going to be? 15. Okay, now let's just call them out. Third one?
17.
Excellent. 19 and 21. Okay? All right. Yeah, well, it's not writing up there for me, but there we go. It'll catch up. The internet is very slow today. Fine. All right? So it's easy to be able to write down which number as long as the numbers are in their specific order. Right? Good. This recording is going to be terrible because the internet is really bad today for some reason. So, all right. So look at this one. This one actually uses a picture pattern, but we can still get the information from it. It says fill in the gaps with the terms from the following table. Now be careful. Sometimes it'll ask you for the number of lines, but sometimes it'll ask you for the number of shapes. So this time it says number of what? Lines. So I want to count how many lines it took to make the shape. But what if it had asked you for the number of triangles in the first figure? You would say what? One triangle, but how many lines? 3 lines. So be very careful. They bounce back and forth when they're asking you these questions. Okay? So, how many lines in the first one?
3.
Right. There are 3 lines making up that first one triangle, right? Okay. Good. Okay. And then the second one?
5.
Okay. So you have 3, 4, 5. Right. Be careful because you have to count the lines, right? Not just decide that there's another triangle to get 3 more lines. So, yes. 7 in the third one and 9 in the fourth one. Excellent. So you can get the numbers for the filling in the table by just by counting them up, right? So from pictures or from numbers. Excellent. Now remember, your assessment at the end is going to contain problems that are created just from this. That's another reason why I wanted to use Education Perfect, because your assessment is going to be from this material. So I want you to see the way things are organized. All right, here's one. Here's a table, but it's got some values, but not all of them. And also, what else do you notice about this table? It's vertical instead of horizontal, isn't it? Yeah. Do you think that's going to matter? No. And for me, I prefer the vertical instead of the horizontal. But it really doesn't matter. Whichever one you like is the one you like, right? And so it doesn't matter which one you use. So let's fill in these numbers. Little n, of course, stands for the what? Number of the term, the number value term, not the value. So that means that the only one we're missing is what? So we have 1, 2, so that means 3. The n's always just go in numerical order. They never change, right? Because that's not the pattern. That's just the counting of the terms, right? First term, second term, third term, fourth term, right? Would you ever have first term, third term, seventh term? No. They're always going to come in numerical order, okay? Now, the pattern ones will change because they always have something different. You're adding 3, subtracting 5, whatever. So let's fill that one in. What's the first one? And y'all can just sing out. 5, then what? 8.
14, 17.
There you go. All right? So you'll be asked sometimes to fill in the missing numbers, right? Pretty darn easy, yeah? Okay. Let's see what they do next. This one, we're just counting the number of dots. I'm not even going to stop to write this. Let's just fill it in. How many dots the first one?
2.
Then the second one has 4.
6.
And then 8. Okay, so you're just counting them up. Good. All right, filling in the gaps from the following sequence. We did one just like that. But what do you notice about the numbers? They're going backwards, so that means they're getting what? Right, so that means that if we were doing this pattern, we wouldn't be adding more, we would be what? Subtracting. Excellent, okay? All right. This one's interesting because if this is a good example of where a pattern and learning a pattern makes perfect sense. Because sometimes you don't see the sense in making a pattern. But look at this one and see if we can help me out here. So the first one, it's the number of stars and the number of points, right? The first star has how many points? 5 points, right? Well, the second one has 2 stars, which means what? 10 points, right? So the third one has 15. So now, okay, are you in your head counting points or what?
5.
Counting by 5s, right? Because I would like for anybody here to count that. That's a lot of points, isn't it? So you can see the pattern easier. The pattern is that it's simply going up by 5 every time, right? Because you're getting 1 more star. Yes?
Right here, it's got like points of words.
Okay, so we're just talking about the points of a star are just assigned as the outside because the inside of them are angles. So they'd be a little different. So we just think the points of the stars being the outside. Good question. I have never thought of it like that. Yes?
The rule for this is n times 5?
So yeah, if you look at that, you're gonna get this number times 5 each time. Mm-hmm. Okay, and we're gonna look at more rules as we go, right? All right. Okay. So in the last lesson, you described patterns and sequence. You can do the same thing when they're presented in table form. So we can describe what's happening in a table. So look at this example. We have fence posts forming a pattern. So we have large fence posts and we have small ones, right? And you notice that the small ones are always between the larger ones. So at the first one, I have how many fence posts? Just one fence post, right? And it's a large one. So one large fence post, but how many small ones in that? Zero. So that gives me, oops, I'm sorry, move that up if I can. I can't without changing it, okay. So that gives me one fence post one large has 0 small ones. In the second one, I have how many big ones? 2 large ones and what? 4 smaller ones. So the second one is 2 to 4. The next one is 3 and 8. All right. So if every one of those is going up. So in this case, we're not describing which term or which number. We're given one value always leads to another value. Could you have 3 big fence posts without 8 small ones in between? Not in this pattern, right? So do you see that those numbers are kind of locked together? They always go with each other. So if I have 4 small fence posts, that means I must have what? 2 large ones. Okay? So make sure that you can read the table backwards and forwards, and you know that you can't just mix those numbers up. And again, you're not going to really see why until we get to the algebra part of this section, but but it's very important. Yes.
So do you just leave the ones like the vertical ones that go across?
Yeah, those are not fence posts. What are they? If it's a fence.
Wires?
So that's the wires. Yes. Yeah. So we're just talking about the fence post. Yeah, this is just a drawing of a fence, right? Okay. All right. So now what we're going to do is we're going to start looking at how to describe the pattern, looking at the table, describing the pattern in words. And the way we're going to be doing this is we're always going to have some number that the pattern starts with, and then we're going to talk about either increasing, which means what operation is increasing? Addition. Okay. Decreasing? Subtraction, right? And remember that multiplication is just repeated addition, so you could also increase by multiplying. And decreasing could also mean divide in some cases, but I don't know how far they take you in this. We'll find out. Okay, here we go. So here's our pattern, an example. It says the pattern is in the second row of the table, and we know the pattern is the second row because the top row is labeled what? And little n, right? So that means the number. So that top row is the number, the bottom is the pattern, capital T. And it starts at what number? Starts at what number? 22. And then what's happening though? Are the numbers getting bigger or smaller? You're subtracting. The numbers are getting smaller, right? Which means that we're not increasing but decreasing. And can anybody tell me by what number they're decreasing? By 2. Excellent. Right? So the pattern is, my battery's running low, it says. The pattern is that it starts at 22 and each number is 2 less than the previous one. So it starts at T and decreases by 2. Right? Now, so if we were going to write that, right, we could say T plus 2 is our pattern. Because whatever number we had in the beginning plus 2 more would make the next number. Right? Yeah. And you know the word previous? Previous just means the one that's before it, right? Okay. All right. So here's one. Look at our pattern. We have our number and we have our pattern. This is the first number of the pattern is what? 5. Yeah, be careful which one you're looking at. And they give you a little drop-down box. And you can just select the right one. And each number is how many more than the next one? 2. And is it bigger or smaller than the previous? Bigger, so that means it's more. And they're going to bounce around and give you words like more, increased by, right? It's really important that you learn the vocabulary words that mean certain operations. So more means what operation? Addition. Well, yeah, but we usually use it for addition, yeah, but it can mean multiplication, to have more of something. Okay? We usually use specific words. Here's our pattern. Okay? The first number of the pattern is what?
17.
17. And each number is how many?
One small.
Yeah, just one smaller this time, right? And it's not more, but what? Less. Okay? So you're going to go through and pick some of these. I don't want to continue forever, but here they're increasing or decreasing? Decreasing by what number?
By 3.
By 3. Okay? So simple number patterns. Okay? The initial value here is what?
4.
4, right? Because remember, initial value is always that t. And it's increasing or decreasing? Increasing. Even though the numbers are going down in the table, right? That doesn't mean they're getting smaller. You just look at it, the number is getting bigger or smaller. So they're increasing by what?
5.
By 5. Okay? And so what we're doing is we're setting you up to be able to write things in algebraic form using letters, okay, instead of the numbers. So describe the pattern in the following table. So what do I mean by describe? What do we need first always?
Is it increasing or decreasing?
Okay, but before that we need a what?
Initial number.
An initial number where we're starting, right? So you got to start in the start, don't you? So we're going to start with what number in this case?
96.
96. Okay? And then are the numbers getting bigger or smaller?
Smaller.
Smaller. So we're decreasing here. And how much smaller each time?
5.
By 5. So we would write the pattern. The initial number is 96 and decreasing by 5. All right? So you're going to be given the numbers and you have to come up with the words to make the pattern work. Okay? Now. All right. So if you look at this particular pattern, for example, we have our table, and from the table they got the sentence, the initial value is 98, and t decreases by 5 each time. So we know that what it's going to do is decrease by 5. So could you tell me then what would the 6th term be? Well, what's the 5th term? 78. So that means the 6th one would be 5 less, or 73. Right? So once you've established a pattern or a rule, then you can always find the next value or the next several values. Okay? All right, so there we get, they give you the description of that. A lot of money. Okay? So, go. Find the next 2 terms in this pattern. See if you can find it on your own.
18 and 21.
Okay? So, what are they?
18 and 21.
18 and 21, exactly. So this pattern, if we were to describe it in word, we would say the initial value is what? 6. And the numbers are doing what?
3.
Increasing by 3, right? Getting 3 more each time. So 3 more than 15 is 18, and 3 more than 18 is 21. How's it looking? Do it in your sleep? There's a duck. I don't know what that has to do with anything with the pattern, but there it is. Okay? All right, here we go. It's all well and good to find the next number in the sequence, but what if you want to find the 20th number, or the 100th number, or the 22,301st number? Yes?
You would go n times
Okay.
the number.
Is it always going to be times? Sometimes? The rule, by building a rule? Right? Sometimes. Yeah. So what we're going to do is we're going to learn how to write a rule for those. And we talked a little bit about this. So we really want to count through all those numbers, 2,000 numbers, right?
We've done rules before.
Yeah. We've talked about this before, but I've still got to go through the lesson. So let's talk about it. So we can just find a rule to look at the numbers. So looking at this pattern, the number sequence, if the numbers increase by 2 each time, right? How does that help you? Increase by 2 each time means that I can take my initial number and simply add 2 every time to get the next number, right? Okay. Now, but what we're going to know is not the pattern. We're going to know the pattern. We're going to know the rule. We need to look at how way to find the n, right? Okay. So what would it be in this case?
N plus n minus 1.
Yeah, because look at it. So she said the pattern is n minus 1.
N plus
Right.
n minus 1.
Plus what?
N minus 1.
Because if you look, let's see if that pattern works. So if it's 1 plus 1 minus 1, we'll put that in a bracket just to make it a little easier. That gives me 1 plus 0, which is what? 1. So we tried n plus n minus 1, and we did the third number. That would be 3 plus 3 minus 1, which would be 3 plus 2, which is 5. So is it working?
Yes.
You bet it is. Yes.
You can also do e times 2 minus 1, which would be the same.
There you go. Remember, if you're adding 2 things that are the same, that's like having how many of them? 2 of them. So 2 times n is the same kind of pattern, isn't it? But you still have to make sure that you're subtracting that 1 out, right? So if you have more than 1 n. So what have you learned from that? Is there only one way to write a pattern always? No. Does either one of them give you a different answer? Nope. They're both the same. They're both describing the pattern. Excellent. So there's different ways to describe it. And one is not better than the other, by the way. Okay, yes?
So in a test, if there are 2 answers, will we write both of them?
You can write either one that works. So if you wrote one with addition or you wrote one with multiplication, either way would be perfectly fine. If it's correct on the paper, then it's correct. Okay? All right. So the numbers increase by 2 each time. In other words, you're adding 1 to the n, but we need to add 2 to the t, right? So looking at the pattern, you can see there where they say it's twice that amount. So that's where we got the 2 or the n and n. Both of those mean twice. Okay? There you go. Awesome. I've never seen a fish do awesome, but that's okay. So look at the 2300 number then. So that's 2 times 2300.
4,600.
Okay? And that way we can find any number. Okay? And then add the 1. Now, what did we change patterns here? Yeah, we're good. So look at this pattern. What is our pattern here? So we got a 1 to get a 1, and then a 2 gives us a 3. So that's that. Sorry, I didn't click on the thing. Yep, it's the same pattern, right? 2n minus 1. So if our number that we're looking for, if our n is, 2301, we can just take 2301 times 2, get that answer, and subtract 1. So 2301 times 2 is what? 2. There we go. And then subtract 1, and that's it. She's already done. She's ahead of me on the math, which gives me 4,601. So if you know the pattern, we don't have to be counting star points or whatever. We can just move forward and get the pattern from there. All right. Okay. If we increase the value of n by some number, we increase the value of t by what? By. Okay. Well, if we're not even we're wondering at this pattern, at any pattern. So in this case, you're increasing it by what?
5.
Is it 5 times that number?
Plus 5.
Okay. So I've gone from 1 to 55. So if I did that as multiply, that's just That's 55. Is that what's happening here? Is 2 times 55 60? No. So, see, they're asking us a weird question here. Let's just see what the... Okay. They're like 5 times as much. By 5 times as much. Let's see. The value of t by 5 times. Is 65 times more than 55? No, we're just increasing it by 5, aren't we?
I think they make me so
Okay, I get it. So maybe by x times. That's a little odd that they would do that, but let's see. We'll check. Okay.
No, I get it. I get it.
5 times as much. They're not talking about multiply by 5. They're just talking about 5 more. Okay. That's a little bad wording for us, but just as long as we know that that's what they're meaning, we're okay. By 5 times as much, right? Not 5 times a specific number, but 5 times as much means 5 more. There we go. All right? So you're going to find a pattern and then find numbers. So I want you to do that on this one. So get together and you can talk with your neighbor, whatever you need to do. Find a pattern, right? And then find the 100th number and see how much that increases the t by. So go. See if you can find it. See if you can find a pattern and think about what we did with the other one. So we got to turn a 1 into a 1, right? Got a pattern for it? No? Yeah? Maybe? Huh? Well, t is getting bigger by 3 each time, right? There you go. There you go. All right? So who thinks they know the pattern? First of all, it says we increase n by some number. You're increasing it. Every time you increase it by what number? So 1 to 4 to 7 to 10 to 13 is always what? 3, right? So we're increasing it by 3, yeah? So if anytime you're increasing by the same number over and over and over and over again, that means that number is going to be your multiplier. Does that make sense? Okay? Yes?
Also, just to add on, the rule is also times 3 minus 2 is the n times 3 minus 2.
Okay. Yep. She got the rule. Sorry, guys. All right. We weren't asking that, but that's okay. So every time we're increasing it by the number 3. That number, whatever you get, so if I was increasing by 5 or increasing by 10 or whatever, that number is always going to be your multiplier. Does that make sense? Because it's added to it over and over and over. That's what multiplication is, repeated addition. So we're multiplying 3 times our n. But if you just took 3 times 1, which is our n here, we would get 1. We'd get 3. Is that what we want? No. So then what we have to do is do some adjustment to get that number to turn into our number here. What do I have to do to a 3 to turn it into a 1? Subtract 2 from it, right? So our conjecture is that it's 3 times our n minus 2. Well, let's see if that's true, right? How could I test it? Yeah, we'll just use the numbers from the chart. And I don't want to go straight to the second one. Let's go to this one, the fourth one. So it's 3 times 4 minus 2. 3 times 4 is what?
12.
Minus 2 is? Is that the number we had? Yes. So you can see that the patterns are easy to find. We're almost out of time, aren't we? Okay, so let's see what they're doing next. Pardon? So we have some. So the 100th one would be?
298.
Right. 3 times 100 and then multiplied. Yeah, there you go. So you'll be able to go. So that's what that times means, is your multiplier. Okay? All right. Same one. They're just finding more numbers in the sequence. There are some of these on Education Perfect on that assignment. If you want to work through some of them, right? If you're getting it and you're fine, don't do them. It's not a grade. But if you're not, then you want to work through some of them to make sure you are. And it wouldn't hurt to go through at least a couple of them to make sure. You're not going to be turning this in, but are y'all worried about points, or do y'all want points for your house or anything?
Yes. Can you pay us with M&M's or marshmallows, preferably? Or Maltesers?
How about points? You are crazy?
Can we get enough points